So before we start, I will talk briefly about how TQ works and what makes it different with another instrument. A triple quadruple is simply means there are three quadruples. So there are first quadruple and then where the collision takes and then the second quadruple. So these three means the triple quadruple. So what makes TQ different with another instrument is the multiple reaction monitoring. So when the sample goes in, it ionized with the ESI for our TQ, and the first quadruple will separate the uh, ion which we want, which is precursor, and then after second quadruple, where the collision works, we will select the product ion with the in the third quadruple. So we can actually collect the what product ion we want. So it makes triple quadruple different with other instrument. So when we goes into mastering page, there are three inlet method, MS method, MS tune method. So as I wrote, inlet method is LC method, MS method is MS method including full scan, MRM or SRM, and MS tune page is for related with the ionization, cone or capillary voltage or collision energy. So uh, when we use TQ, actually, in most of time we want to do quantification analysis. So in case of quantification analysis, we first have to do optimization. So in the MS Tune page, there are ESI plus source or fluidics. In the optimization progress, we will find the best cone voltage or capillary voltage uh, for good ionization of our sample. So this three is the each start infusing button or refill the syringe button and then purge the syringe button. And reservoir is this one. You can put the wires on this site. And then flow state is LC or infusion. So when we uh when we are trying to optimization uh the sample which we want to quantify, we will put the sample in reservoir A or B, and then we can refill the syringe with that, and then set the flow state as direct injection, and then start infusing. And when the samples are infusing, we can do some works in this page, the ESI source page. First, capillary and cone voltage. We can manually change these voltage with the like 0.5 values and then uh find find the results which the intensity is highest. And the with the capillary and cone voltage, we can find the precursor ion, which precursor ion and the voltage which their intensity is highest. And after finding out the precursor, we can find out uh, the collision energy, which makes the product ion's intensity becomes highest. So in the highest this line, there is API and collision gas. So just turn on these two gases, and this button is MS mode and MS mode. So uh, actually, when we do just capillary and cone voltage finding, we can just turn on the API and the MS mode. And then after we find out the adequate this voltage, we can turn on the collision gas and MS mode and find out the collision energy. Uh, we have to turn on the or operate the we can turn on the triple quadruple with this button. So this is when the green light's on here, it means that the TQ is on. And actually, I said that we have to manually change these voltages with the like 0.5 value. In each time, we can click this button to gather the data. So here you can see that capillary voltage 3.5, cone voltage 40, cone energy. I think this is collision energy 12. So we can manually as we change these values, we can get the data with this button. And we can select the Doppler scan or precursor scan in here. And then for this masses, we can set the mass range and the mass that we want to see. And the next is MS method. For MS scan, it's similar with other. It's actually simple. You can set the mass range and time and convert it. We can select the whether we will use tune page or we can select the converters in here. And then the ionization mode and data profile is here. And scan duration we can also set in here. So this is like uh it's like intuitive. We can I think everyone can use this MS scan make this MS scan method. And for MRM method, uh, we do optimization and find out the adequate cone voltage, capillary voltage, and collision energy. So we can put the parent ion and daughter ion, and then each of their cone voltage and collision energy in here. So, and then actually Professor lastly talk about the PIC scan. So we can select the PIC scan here. Uh, so as you can see, when we put these three isoprocar parent and daughter scan in here, we can check it on here. mRNA of three mass pairs on time 0 to 5. So just put the chemicals that you want to quantify and their daughter ion, parent ion and daughter ion mass and convertage and collision energy. And for the sequence, uh, actually this file name and file text is just what you want to note about it. And then you can put the MS file, MS tune file, and inlet file, and then the bottle uh, location and the injection volume. So the things that we have to check before run in MS tune page is like this. First, you have to check the ionization mode, and then check that both gas is on, and also you have to uh, check that you collect the MS mode, and then you have to check the flow state is on LC, not in Fusion, and you have to check the instrument is operating. Mm. You have to check the instrument is operating. Oh, thank you. Is there any question?
Yes, Sungjun, I
Mm,
have few questions.
mm,
First of all, when we have to set the MS method,
mm.
when is the time when we have to select the parent scan and daughter scan in that one? What is the appropriate time to select which option before this one? Before this one,
This one?
go one screen back. Yeah, this one. in the acquisition.
Ah, you mean that when we have to set the function as starter scan and
Yes,
when to precursor?
yes.
Till finding the comb voltage, we have to set as the precursor scan, and when we are modifying the collision energy, then we have to change to a starter scan.
Okay. And another question is in the MS scan, in the next one. Yeah, this one. So do we have to set this method separately, like for the start of the M over Z and the end of M over Z for the MRM method, or it is separate from the MRM method, this MS scan method?
This is totally different one. This is just for MS scan, and if we want to do MRM, we don't have to make this one.
Yeah, then we don't have to make this one.
Mm,
Okay. And another thing, can you please go to the next one? Yeah, in this one. As you know, there are three fragments in this one for
mm,
the
mm,
isoprocarb.
mm, mm.
So, as you know, we cannot select PIC for all of them.
Yes.
So we have to select one of them.
Mm.
So kindly tell us which one we will select out of these three fragments. Either it is the
Mm.
quantifier ion or the qualifier ion.
Actually, about this one, I am still finding, but I set the PIC as the product ion which shows the highest intensity.
Okay, okay. So Ahmed, can you please tell us about this? If because last time you performed experiment, and maybe you know that how you selected those things, or whether it was based on the intensity or some other parameter. If you can.
Could you please repeat? I was busy in something else. What
Okay.
was the question?
As you can see on the screen,
Yes.
isoprocarb.
Okay.
Sungjun, turn off your mic, please. Okay. He said that we can select PIC out of these
Okay.
three
Yeah.
daughters. So I wanted to ask which one we will select.
Actually, we have quantifier and qualifier ion. So normally the high intensity peak we select as a quantifier and the low intensities are considered as a qualifier. PIC, we are usually using PIC for confirmation. So that means that we are using that fragment for qualification. So as for my knowledge, I think the low intensity peak should be considered as a PIC. That is a qualifier ion. Because quantifier we are selecting as a high intensity peak.
What is the reason for this? If
Because that fragment we are using PIC for confirmation. Confirmation we are doing that qualification. For quantification we are using the high intensity peak. So but PIC we are using the PIC just for the confirmation, and we know that for confirmation we need to see the low intensity peak.
okay, so you mean to say that if we select the low intensity ion out of these three daughters,
Yes.
we will be able to pinpoint that this particular daughter ion is coming from that parent ion.
Yes, that will be confirmation of your compound.
Okay. Because the low intensity ions create ambiguity. So we have to be sure they are coming from this parent. So we should select the low intensity for the PIC out of these three.
Yes.
Okay. Thank you.
Thank you.
Any other questions, please ask. I am done for this.
I wanted to ask about here the three daughter ions, right? 77, 95, 137. So here the collision energy is different for each of the daughter ion. So does it gives to each that MOR that the different collision energy in the MRM?
Oh, can you ask one more time? Can you say one
So
more time?
it's, let's say the three daughter ion is here, and here three different collision energy. So does it give at the same time three different collision energy, or how does it work?
Actually, that three different collision energy means that each collision energy makes this product ion highest intensity, and uh, you are meaning that how it works. Like there are three collision energy, and then
One
how.
scan will be 28, and another scan will be 14, or third one will be 8. Is it like that?
Uh,
Imran, did you understand my question?
Yeah, I understand, but I think it will be the ramp
Nice.
capillary, yeah, ramp energy, and it will be in this range. And in as you can see in this one, cone voltage is fixed, but collision is changing. So at these particular values like 28 and 18, we will get the highest intensity of 77 daughter first one.
Then it's going by RAM.
Yeah, it is like ramp energy.
Uh, how about if we choose only three daughter ion and one parent ion, let's say, what about another peaks that only these peaks will be shown, and or that peaks will be ignored, or how?
Actually, that is why we are selecting MRM method,
Yeah.
because it will highlight only these selected peaks. There will be other peaks, but these will be there. And the reason we are selecting PIC is that we have to be sure they are coming from the same parent ion that we are concerned. So this is the main thing of MRM method. Okay.
I see. Yeah.
Any other question, people?
Yes, Samjun, I have a question in the dwell time. So, you have not used auto dwell. You used 0.025 dwell time. So, is there any reason, or do we, when we are doing optimization, so do we need to optimize the dwell time?
uh, in this picture is not what I is not my project. I just get the image from that. But as I just use AutoDwell.
Uh, can you please explain it? Do we need to optimize the dwell time or not? Or what is the effect of the fragment? If there are less fragment or more fragments, so do we need to optimize dwell time?
Mm, Actually, I always use just AutoDwell. I never optimize the dwell time, so uh I'll check about it.
Oh, okay, thank you.
May I ask one more question? Actually, when we do optimize this sample, we need a much more sample, right? What if we have a like limited sample? So how are we gonna do that?
Ah, uh, Actually, when we doing optimization, we almost fill volume like 25 uh 250 microliter. But can you explain uh how small the
Let's say we have only one vial. I mean, the
mm,
LC vial. So do we need to do in the LC, right then?
yeah. ah this is the standard we can do with the standard. So is there any case that standard will only one LC vial?
I understand. If it's standard, it
Mm.
makes sense. Yes.
Okay. If no one has any question,
I
then
have I have one
okay,
more
okay,
question from
okay.
Songjun. Songjun, did you try to optimize by IntelliStart?
No, I never tried.
Can we do with the IntelliStart?
Can we, if that we can use the IntelliStart?
Yes, actually, can we do optimization with the IntelliStart? Because as far as I remember, we can get the collision energy, cone voltage, and dwell time all from the IntelliStart.
The IntelliStart is not good.
Not what?
It's not much. It's separate. It's different.
Can you people speak? Can you people speak in mic so we can also listen?
When can you did it with manually and until start, so the values are different, right?
Just the engine start is not. When there's automatically.
Yes, and then you compare with manual
Yeah,
optimization.
different. There's no match.
Okay, thank you.